Hi guys, my name is Terry. In this video, I'm going to go through with you the Additional Mathematics Form 5 at Maths textbook for Chapter 8, Kinematics of Linear Motion, Formative Exercise 8.2. All right, let's get straight to this. Okay, again, if you enjoyed this video, kindly like, subscribe, or leave us a comment. Now, let's go do the first question. Yeah. Question number 1. So here we have a diagram that shows the displacement function, the velocity function, and the acceleration function of a particle here, that a particle that moves along a straight line from a fixed point O. The time is given from 0 to 4. You can see there are three functions here. Your displacement function is given by the pink line, pink curve here, the quadratic curve. Velocity function is a straight line, a slanting line here, a linear form, and your acceleration is a constant horizontal line, the green one. Okay, so based on the graph, determine the initial velocity. Well, initial velocity, we have to look at the purple line here. That means when t is 0, you can see your velocity is -2. So we can straight away write, I think I don't have to write this. Okay, I'll just write when t is 0, v is just -2. In the unit is in meter per second, right? Okay, now time in second, time in second, the particle passes through fixed point O. Now we know the particle will return to point O when your displacement is 0. Now, so let's focus on the pink curve here. When your displacement is 0, s is 0, the time t is 3 seconds. Okay, again, if you don't want to write the unit, it's fine. I just write 3 will do. C, the minimum displacement of the particle. You can see here, the particle has the lowest or the smallest displacement here when t is 1 and your displacement is -4. So we can say minimum displacement is just -4. You can write -4 meter. All right, then let's look at part B, the total distance traveled in the given time period. Okay, to find total distance traveled, you can see here, the particle actually went from -3 to -4. It means the distance here, maybe I just use a different color to show you. This distance here is 1. And then from -4 to 5, it goes up by 9, right? So the distance or the total distance travel, it go to the left by 1, it go to the right or up here by 9. So your total distance 1 plus 9, which is 10 meter. Okay, next, the range of time in second when the particle moves to the right. So to know whether a particle moves to the left or right, we have to look at our velocity. A velocity sign tells us whether it's going left or going right. If your velocity is positive, it's moving to the right. If your velocity is negative, it's moving to the left. Okay, maybe I just highlight here. Now, when t equals 1, the velocity is 0. When t is less than 1, velocity is negative, right? That means moving to the left. When t is more than 1, the velocity is positive. Can you see this segment here? Yeah, the particle is moving to the right, is positive, right? So the range of values of t, we should write here that for v more than 0, t must be greater than 1. Yeah, greater than 1 second. You see, yeah? This range here, more than 1 second. All right, oops. Okay, let's move on to the next one. Okay, question number 2. All right. So here we have a diagram that shows the displacement time graph, okay, of a particle moving on a straight line. And the coordinates are given here, 0, 1, 2, 3, 4, 3, and 6, 0. Find the values of h and k. Okay, so let's start with this equation, s equals to h e squared plus k. Now, when you start the clock, t is 0. Yeah, when t is 0, your displacement is actually 1. You see, displacement is actually 1. So we can sub 1 equals, let's put 0 inside your t. That means that your k is actually 1. Okay, to find the value of h, I need another point. Let me take this coordinate 2 and 3. That means when t is 2, displacement is 3. So let's sub inside s with 3. H is an unknown. t is 2, you got to square it. Your k, we know, is already 1. So let's bring this over. This is 3 minus 1, which gives us 2. 2 squared is 4, so you get 4h here. So h is 2 divided by 4, which is 1 over 2. So I've got the value of h and k. Yeah, fairly simple. Now, next, find the instantaneous velocity at t equals 1, t equals 3, t equals 5. For t equals 1, it still follow this function here. So we can rewrite here, your s is now half t squared plus 1. Your h is half, your k is 1. So when t equals 1, let's sub inside. Okay, you're finding the velocity, sorry. You need to differentiate first. Oops, you're finding the velocity here. So the velocity is the gradient of displacement time graph. But since your displacement here is a curve, you need to differentiate. So when I differentiate this, I bring the power down. Half times 2 is 1. So it's 1t, reduce the power by 1. This is t power 1. Now you don't have to write the 1. You can just, you don't have to write t power 1. Okay, sub t with 1, your v is also 1. Yeah, 1 meter per second. For Roman 2, when t is 3, you can see t equals 3 lies between 2 and 4. So this is a horizontal line. So that means the particle stays at displacement of 3. Basically, the particle is not moving, right? So when the particle is not moving, what's your velocity? Your velocity is 0. Okay, and lastly, for t equals to 5, now you notice this is a straight line. It's a slanting line. That means for a slanting line like this, the gradient represents the velocity, but we can find the gradient by using y2 minus y1, x2 minus x1. Now up to you, you may want to write this as 4, 3. This is 6, 0. So my gradient, my velocity is my gradient, which is 3 minus 0 over 4 minus 6, negative 3 over 2, or you can write negative 1.5. So throughout t equals 4 to t equals 6, the particle actually travel with a constant velocity, yeah, because the gradient is constant. Unlike this part here, where there is a curve, the gradient is ever changing, yeah, depending on your gradient function. But this one is not, it's constant, so we can just find the gradient for this line here, and then you get the velocity to be negative 1.5. Okay, now let's move on to question number 3. Okay, this question is a bit unique. I would say it's something that is not really in your syllabus because you don't know how to solve. You don't learn how to solve a cubic function. But I can just show you, explain to you. This idea of solving cubic function is in IGCSE, is in A levels, but not in Form 5 SPM, and not really in the syllabus. All right. So first, we want to express velocity function v and acceleration function a. So we know when you differentiate displacement, you will get acceleration. So you will get velocity. So when you differentiate this, you get 3 t power 2. Bring the power down, copy t, reduce the power by 1. Bring the power down, 5 times 2 is 10. Copy t, reduce the power by 1, 1. This is linear form, differentiate negative 8t, you get minus 8. And when you differentiate 12, 12 is a constant, you get 0. So that's your velocity function. To find acceleration function, differentiate 3t squared, you get 6t. Differentiate minus 10t, you get minus 10. There you go, that's your acceleration function. Okay, determine the instantaneous velocity and instantaneous acceleration at when t is 3. Very simple, we sub t with 3, find your velocity. So it's sub inside 3 squared minus 10 times 3 minus 8. So this is 27 minus 30, negative 3 minus 8, negative 11. Yeah, you can use a calculator. And as for your acceleration, we put 3 inside here, 6 times 3 minus 10, 18 minus 10 is 8. Okay, I've got my part A, I've got my part B. Okay, next part C. Find the value of t when the particle is instantaneously at rest. Now remember, particles at rest when your v is 0. Yeah, instantaneous rest. So 3t squared minus 10t minus 8 equals 0. Let's factorize. 3 times 8 is 24. What's the factor of 24? To get 10, I must use 12 and 2. I can't use 6 and 4 because 6 and 4, this will be plus. Here, if this is a minus, the middle term should be the difference in your factor, right? We call it the sum of roots and product of roots. It should be the difference of the factor of 24. So we take 3d. I want to get 12, and I want to get a 2, right? So to get a 12, I put a 4. To get a 2, I put a 2. 12 is a minus. 2 is a plus. Now we know time is always more than 0. Yeah, when you start the clock, t is greater or equal 0. Anything smaller than that, we cannot take the value. So t is just 4. So the particle comes to instantaneous rest, yeah, when t is 4. All right, that is part C. Part D, find the value of t when the particle is at O. Now this is where I mentioned that this is not really in the syllabus. When the particles at OS is 0. So now you'll be thinking, how do you actually solve this equation? So a couple of things. Okay, I can just give you an introduction how to solve a cubic function. Right now, most people will use a calculator and say, okay, I use my calculator. I press 5 for equation. This is like a cheating method. You put a 4 here, then you put 1 equals -5 equals -8 equals and 12 equals. There you go. Your t value will be 6, 1, and -2. But how do you actually show all this? All right. Now, the first thing you need to understand is that the first step is always a trial and error, because when you factorize this, you should have 3 brackets, 3 linear terms, right? So this will be a t and a t and a t. But these 3 number here, right? Let me say this, and this multiplied together is going to give us 12. So one of them, right, should be, we can say it should be a factor of 12. Now, when I say factor of 12, I'm referring to 1, 2, 3, 4, 6, or maybe 12 itself. Now, it can be positive, can be negative. So the first step we have to do is we have to do trial and error. Now, we know that if you want to find a solution to this equation, we must pick a number and sub inside. And if it gives us 0, that means that particular number, that particular value of t will be the root of the equation. So we can use your calculator like this. We can use alpha x cubed minus 5 alpha x squared here. Then you minus 8 alpha x plus 12. All right, let's equal first. Now we're going to do trial and error. Press calculate, pick a number. Let's start with 1. Does it give us 0? Yes. That means if I sub 1 inside, this is your displacement function. When t equals to 1, let me use like that. When t is 1, your left-hand side, or should I just say s, your s, equals to 1 cubed minus 5 times 1 squared minus 8 times 1 plus 12. Picture this: 1 minus 5 is minus 4, minus 4 minus 8 is minus 12, minus 12 plus 12 is 0. So that means we know that t minus 1, this bracket, is a factor, right? Now, remember, you want to factorize this first. You want to factorize t cubed minus 5t squared minus 8t plus 12. But we know t minus 1 is one of the factor. But we need to figure out the rest of this. So now the front and the back terms is kind of easy because we know that t times what will give us t cubed? Well, the answer is t squared. And then think negative 1 times what will give us 12? Answer is minus 12. Now the challenge is the middle term that we do not know. I'm going to call it a b with a t, because this is going to be a quadratic. A linear times quadratic will give us cubic. So I need to find the value of b. So to solve the value of b, what we can do is we can use comparison method. We basically compare the coefficient. One of the coefficient, maybe I compare t times bt. This will give us bt squared. That means the coefficient of t squared with this 2, negative 1 times t squared. So this is what, or how we write. We say we compare the t squared, the coefficient of t squared. In this case, it will be here the green one, b times 1, which is b, minus 1 times 1, which is minus 1. So b minus 1 must equals to, what is my coefficient t squared here? Negative 5. So my b is now minus 4. Okay, so once you know your b value, then it's quite easy. We know that this whole thing, t minus 1, t squared minus 4t minus 12 is your displacement function as is now 0, right? I'm going to write 0 here. And I can factorize this further, factor of 12 to get 4. I should use 6 and 2. I put 6 and 2. 6 is minus because the final answer is -4. Bigger number is negative, smaller number is positive. Now we know t is more than 0, so your t is 1 or t is 6, right? So there are two values of t for which the particle returns to 0.0. Yeah. Okay. Remember, this is actually not in the syllabus. You don't need to know how to solve a cubic function. But so, I mean, the textbook decided to give you a challenging question like this. Yeah, you have to use your brain to think, right? Yeah, it's a little bit off the syllabus. Okay, last part. Find the total distance traveled in the first 6 seconds. Okay, now to understand the total distance traveled, right, we can actually use the graph of velocity time. All right, okay, you can use a number line. So normally what I will encourage my student to do is to sketch the velocity time graph. We can see that velocity time is a positive. It has a positive coefficient, meaning it's a smiley face. So we can do a rough sketch like this, okay? And we know it will cut the x-axis at -2/3 and 4. So this is -2/3 and this is 4. So the y, the axis is here. This is your velocity and this is 6. Since you're finding total distance traveled in the first 6 seconds, that means, remember, area under the velocity time graph is the distance traveled, in this case 0 to 4 and 4 to 6. So, but you don't have to use integration. This is just to tell us that the particle actually goes to the left first and then it goes to the right. Now, you can even use a number line, right? Like this. We know when you start the clock, t is 0 and the particles at 12. Yeah, that means let's say 0. I put 0 here, 12 is over here. When you start the clock, the particles going to the left. You can also tell by looking at the initial velocity. When t is 0, v is -8. That means it's going left. Huh? Negative sign for velocity means it's going left. So it goes to the left. And now remember, just now we got t equals to 1. That means the particle returns to 0.0. When t equals 1, this t equals 0, this t equals 1, is at 0.0. At t equals to 2, does it make a U-turn? Yeah, it makes a U-turn at 4 here. You can see when v is 0, it makes a U-turn at 4. Here, I put t equals to, okay, maybe I put here, t equals to 4, it makes a U-turn here. And then at t equals to 6, here, see this 6 here, it returns to 0.0. T equals to 6. So what we need is to find what is the displacement when t equals to 4, right? So just use your calculator. When t equals to 4, S4 is, let's sub inside, you get 4 power 3 minus 5, 4 power 2 minus 8 times 4 plus 12. This is 64 minus 80, -16. -16 and plus 12 is -4, -4 minus 32. I got -36. So this is -36 here. See? All right. That means that the particle starts here, it goes to the left, make a U-turn, it comes back, returns to 0.0 when t equals 6. So your total distance travel, yeah, will be, you can actually just look at a diagram and calculate. But if you don't want to draw this, is fine actually. We can just see is S4 minus S0, S6 minus S4. S4 minus S0 and S6 minus S4. Now we know your S4 minus S0 is going to be negative because it's heading to the left. I can see from the velocity time graph, or I can draw this, right? So I modulus it, right? S6 minus S4 is going to be positive, right? We know S4 is -36, S0 is 12, because here when t is 0, S is 12. Okay, and then S6 is going to be 0 because we know it returns to 0.0 when t is 6. S4 is -36. So this is 48 plus 36, I'll put here 48 plus 36, answer is 84. So we can actually map it here. This one is 48 because I'm going to the left by 48. I'm coming back by 36. My total distance travel is 84 meter. Yeah. All right. I hope this is okay for you. All right. Well, if you enjoyed this video, yep, and you want to find out more about books, our notes and tutorial series, topical practice, intensive revision, or even our past year question book, yeah, you can find out more from us. Find out more by going to our website or even our contact us, yeah, Shopee, so on. Thank you for watching this video. See you in the next one.